This is Algebra 1, Unit 8, Lesson 4 on completing the square. Okay, so now we have two forms of a quadratic. All right, we have standard form. That's y equals ax squared plus bx plus c. That's standard form that we usually see a quadratic in. And then we have it shifted, or the vertex form. All right, this is the vertex form where h and k are the vertex. So how do we switch from this form to this form? Well, we use a process that's called completing the square. So how do we get to completing the square? It comes from a pattern we find by squaring a binomial. All right, so let's look at x plus 5 squared for a second. We're going to square that. We want to look at the relationship between the quadratic we end up with when we're done. So remember, x plus 5 squared really means x plus 5 times x plus 5. So you have to do your box or your arrow or double rainbow, however you want to do it. I'll do the box over here so we have it. X plus 5, x plus 5. This is x squared, 5x, 5x, and then 25. Add your boxes up, you get x squared plus 10x plus 25. So now you can see this is a standard form trinomial. You've got three terms. Okay, what is the relationship between the b term and the c term? Okay, so this is the b term and this is the c term. Okay, so what we want to know is how does the c term compare to the b term? All right, well, this is 25 and this is 10. The c term is if you take the b term and divide it by 2 and then square it. Okay, so the c term we said was 25. So the b term, if I take half of that, will equal half of 10 over 2. So it's 10 divided by 2 squared, which is 5 squared, which equals 25. So that's pointing out the relationship between that. All right, does this work for a minus 1 as well? Remember, x minus 3 squared is x minus 3 times x minus 3. All right, so let's do the box. X minus 3, x minus 3, watch your signs. X squared minus 6x, or minus 3x, sorry. Thinking ahead of myself here. Minus 3x minus 3x. Negative times a negative is a positive 9. So when I combine my terms, I get x squared minus 6x plus 9. Okay, so again, let's look at the relationship to the b and the c. This is the b, and this is the c. Okay, so is the c equal to half the b squared? Let's see if it is. All right, so c is 9. Half of the b would be negative 6 divided by 2 squared. Well, negative 6 divided, oops, squared, not cubed. Negative 6 divided by 2 is 3, negative 3 squared. Does that equal 9? Yes, it does. So that's the relationship between that. Now, how do we use that for perfect squares? All right, well, you have to be able to take a trinomial like this, that is a perfect square, and write it like this. So let's factor this, x squared plus 2x plus 1. We're going to write it as a perfect square. So we want to write it so it's something quantity squared. Well, to do that, I need two factors. Let's do my two factors. All right, I'm going to factor this. This is x squared, this is 1. So this is going to be x and x. This is plus here. They're both plus, so it's plus plus. And it's got to be 1 times 1 gives me 1. So this gives me 1x, and 1x gives me 2x. So this is really x plus 1, which we can write as x plus 1 squared. Okay, let's do a minus 1 so that we can get it. We want to get this to be equal some quantity squared. So this one's going to be x plus 1 squared. I forgot to write that. All right, so I want this to be some quantity squared, so let me factor this. This is x squared and 9. Now, since this is positive here but negative here, it's the same sign, but they both have to be negative. So it's got to be minus minus out here. So x and x. What gives me 9 would be 3 times 3, which gives me negative 3x and negative 3x. So this is actually x minus 3 times x minus 3, which I can write as x minus 3 quantity squared. So if I want to write this as a perfect square, x squared minus 6x plus 9 is equivalent to x minus 3 squared. Okay, so that's enough practice on that. We'll skip this one for right now. If you want to work this one out, this one's actually going to be x plus 10 times x plus 10, which gives me x plus 10 quantity squared. Okay, now that we understand what a perfect square trinomial is, we're going to use it to do what's called completing the square, to turn part of a trinomial into a perfect square binomial. Suppose we wanted to write y equals x squared minus 4x minus 1 in shifted or vertex form. Remember, shifted form or vertex form is y equals a times x minus h squared plus k. Now notice this does not look like this. We want to put this in this form. Okay, the problem is this minus 1 right here doesn't make this a perfect square trinomial. I can't factor 1 and get 4. It doesn't work. So what we're going to have to do is only do part of the trinomial using completing the square. All right, so let's work through the process. We start out with y equals x squared minus 4x minus 1. Okay? Your first step is to move the c term, which is the constant term, to the other side of the equation. So I want to move this over to the other side. So to move it to the other side, what do I have to do? I have to add 1. Okay, so that gives me y plus 1 equals x squared minus 4x. Okay? All right, now, we're only worried about this half of the equation. We'll worry about the y stuff later. But this half of the equation, we want to turn into a something squared. So what we're going to do is take half of the b term and square it. Which one of these terms is the b term? It would be this one, right? This is the b term. All right, so if we take half of the b term, it would be negative 4 divided by 2 is negative 2. Okay, so we take half the b term, and then we square it. Negative 2 squared is going to be 4. All right, so this is what we did. Y plus 1 equals x squared minus 4x plus, let me do it down here, plus negative 2 squared. And since we do it on one side, you have to do it on the other. You can't just do it on one half of the equation. Okay, so what is negative 2 squared? We said it was 4. So this is going to be y plus 1 plus 4 is equal to x squared minus 4x plus 4. So if you combine, y plus 1 plus 4 is just going to be y plus 5. Okay, so now we want to make this into a perfect square trinomial. All right, so we ended up with y plus 5 equals x squared minus 4x plus 4. Okay, so now we want to factor this part right here. I'll do it over here. And this should be a perfect square trinomial. Let's see if it is. X squared, 4. If this is negative here, these both have to be minus. So this is x and x. What gives me 4 would be minus 2 times minus 2. And that adds up to 4 in the middle, and that works. So this is actually going to be y plus 5 equals x minus 2 times x minus 2. Well, this can be written as y plus 5 equals x minus 2 squared. All right, so if you notice now, this is looking more like the perfect square trinomial now, isn't it? All right, now notice, you may see something interesting here. We added back here, what did we add to both sides of the equation squared? What did we add right here? Didn't we add negative 2? See that right there? Well, look at your factor here. What is your factor? Isn't that also negative 2? All right, so as a trick, when you do this, when you factor this side, when you do that, if you can remember what your half your b was, that's going to be your factor that goes there. All right, now the last step is to move the c term back to the other side. So we have y plus 5 equals x minus 2 quantity squared. So move the c term back to the other side, which is the 5. So we're going to minus the 5. So now this is y equals x minus 2 quantity squared minus 5. And that is in vertex form. So what is the vertex of your parabola? Well, according to this equation, this is your x value without the opposite sign, so it's going to be 2. This is your y value. So this is your x, this is your y of the vertex. So this is going to be 2, negative 5. All right, if we want to verify that on the graph, this is the graph of y equals x squared minus 4x minus 1, the original equation. If I look at 2, negative 5, 2, 1, 2, 3, 4, 5. It works. Okay, so now if I want to verify this on Desmos, I can do that as well. All right, if I do the original equation, y equals x squared minus 4x minus 1, that was the original equation. And then if I do the shifted form, y equals parenthesis x minus 2 quantity squared minus 5. Notice the parabolas line up perfectly. You can also do this on your calculator. See, the red one and the blue one, if I turn the blue one off, there's the red one, there's the blue one, they match perfectly. If you graph them in your calculator, they'll do the same thing. They'll overlap. So if you have the right equation, the two equations will overlap. All right, let's try a couple examples. We're not going to do them all, but we'll do a couple. All right, so we want to write this by completing the square and identify the vertex. So our first step is to move the c term. Add 2, add 2. Y plus 2 equals x squared plus 6x. All right, then I want to take half of the b term and square it. This is the b term. Half of that is going to be 3, and I'm going to square it. And since I did it on one side, I've got to do it on the other side. So this is going to be y plus 2 plus 3 squared is 9 equals x squared plus 6x plus 9. Combine my terms here, I get y plus 11. Okay, now x squared plus 6x plus 9, if you factor this, remember it's going to be x plus and x plus the same thing. Well, what's the plus going to be? It's going to be this. Okay, so this is actually going to be x plus 3 quantity squared. You can factor it off to the side if you want to. It will be x plus 3, x plus 3. But if you know this trick, whatever's there will be your factor here. Okay, so then just move the 11 back to the other side, and you get y equals x plus 3 quantity squared minus 11. So what's your vertex? All right, remember the x is always the opposite sign, so this is going to be negative 3. The y is going to be the same sign, negative 11. There we go. Okay, let's try a subtraction one. Y equals x squared minus 2x plus 11. We subtract the 11, and we get y minus 11 equals x squared minus 2x. Okay, now we want to take half of the b term and square it. This is the b term. It's whatever's on the x. Half of negative 2 would be negative 1 squared. So since I add it here, I also have to add it here. So this is y minus 11 plus 1 equals x squared minus 2x plus 1. Combine your terms, you get y minus 10. Watch your signs. Then x squared minus 2x plus 1 will be the factors of what squared? Well, it'll be x, and what did we take half of here? It'll be x minus 1 quantity squared. Move the 10 back to the other side. X minus 1 quantity squared plus 10, and your vertex will be at 1, 10. Opposite sign, same sign. All right, so maybe I'll have you do a couple more of these tomorrow, but for right now, that's the general idea for completing the square.